So today's video comes about because of a question I often see on the internet, and that question is, do I have to match my probes, my scope probes, to my scope? This 50 megahertz scope probe, does it have to be used on a 50 megahertz scope? And the answer to that is no. If this scope, or if your scope is happy with this probe, and this probe adjusts to your scope, and your scope is 100 megahertz, basically you're going to be good to 50 megahertz with this guy. Now, what the limiting factor is will this match, any of these, will they match to the input capacitance of your oscilloscope? They have an adjustment on them, and that's underneath this cover right here that spins, and you give it a bit of a twist and it'll come loose, and then you spin that around, and there's an adjustment hole right there. And inside of there's a small matching network that's in here, a bit of passive components, and we have a tweaker here that goes in there. Now you'll notice this guy here has a very small end on it that is metal. That's because sometimes these guys can get a little bit difficult to turn, and simply using just a plastic one like this, you might just take the end of it off of there because it's that tough, and these wear out really quick. So they'll put a tiny bit of steel or whatever in the end of this, and the rest of it's plastic. And then you're not loading that thing down on the inside there when you stick this in there to adjust it. Fits in that hole. You use the matching network or matching square wave that comes off of the front of your scope. There's usually a little 1 kilohertz square wave that's present there for you to match your probes to your scope. You do that adjustment, cover this back up to keep all the dust and stuff out, clicks into place, and you're good to go. Some of the probes, the adjustment's not on this end, it's actually on the scope end where it plugs in down here. This is a Hewlett-Packard 300 megahertz probe, and this one is actually, it tells you right on here what sort of range of input capacitance that it handles. So if you take a look at the front of your scope, often it will tell you, and if it doesn't tell you on the front of your scope, it will tell you inside of the book for the scope of what sort of capacitance, the input capacitance that your scope has. And if that capacitance for your scope falls inside this range, this probe should be able to match to your scope. So even if your scope was only 100 megahertz, say, and but it falls, the input capacitance falls within this range, this is a 300 megahertz probe, you'll still be limited to the 100 megahertz because of the scope itself. These guys here are 150 megahertz probes, very similar to this one. You'll notice one thing about these, there's a little pin on the end here, and on a lot of scopes there's a small ring around where it plugs in on the BNC connector, and that little pin hits that little metal ring, and it tells the scope that this is the 10 times probe. So the scope sets itself and it adjusts its display to match the 10 times on here so that you don't have to be doing it in your head all the time. This has been taken care of with that little pin right there on the appropriate scope. Not all scopes have that. This is the same as this guy for the adjustment underneath here. You look underneath there and you'll see there's a little adjuster there, much like this guy. But this probe also has a high frequency compensation, which is not normally adjusted. It's often done once. And if you take this probe, and if you read the book for this guy, you take this and you pull it down further, and you'll see there's 3 adjustments under here. There's 3 little tweaking spots inside of there. That typically only has to be adjusted if you've changed the scope. You've gone to a new scope, and this really is not working well. But normally those are adjusted once, and they're quite often left alone, and that's why they're not readily accessible here. This is a switched probe. It has a switch on it from 1 times to 10 times. So it's the 10 megahertz, of course, on 10 times, and then it's direct on the 1 times. Now I have to speak about direct probes here a little bit for this guy, and when this is on 1 times, they're not quite as direct as you might think. You may think that when you switch this to 1 times, it's just like a piece of wire that goes straight through here, but it's not. It actually has a little bit of resistance to it. And it's the same with this one here from Tektronix, this P6101. And if you take and actually measure them, so you stick this on 1 times and you take your multimeter and you put it on this end and tap it to the middle of the the BNC on this end, you'll get these sort of readings out of it. These will be about 170 ohms. The tech here, the P6101, through it is actually 323 ohms. So what we see here is, in our situation when we actually have it hooked up to our scope, which has a 1 megohm input, is a very common amount for a scope. That 1 megohm input is in series with this very small resistance, which is not a big deal because it only makes, even this is the highest resistance one out of these, all of these that I have here. Even that is only 0.03%, so it's nothing. I mean, your changes in temperature will be bigger than that for your errors. So that's not a real thing. Where it does come into play is when you think that your probe, like this guy, you think that's just a piece of wire in here, and you're going to stick this on the output of your, say, your audio generator or something. Now you've got your audio generators appearing at the tip here, and you're going to reach down inside of something, and the levels don't seem quite right. You're working on a 600 ohm system or something like that. Well, there's 323 ohms through this thing into your 600 ohm system. Stuff's not going to work out quite right. Your levels are going to be low, and you'll be wondering why. So take your ohm meter across the tip into your center conductor here, and just check, just so you know. And another thing that we have here, a very handy, nice little thing to have, are these little springs that come along with these probes here. So if I want to get very close and I'm working at RF frequencies, I can pop the top of this guy off. I can take and put this little spring on here, and it can be a little bit of a chore to get it on there. So you have to kind of spin it so that it opens up the spring as it goes on. And then when I'm done, I've got ground right down here, and my probe is right here. So if I'm trying to probe something that's very quick, often if you have a very long lead here, just the inductance in this and just the way all this works can give you some weird looking square waves or weird looking readings, that sort of thing. And it's because of this. You always want to try and, as best you can, keep this lead as short as possible, and they do come in different lengths. So you're trying to keep it not as short as possible, and this is pretty much as short as you're going to get. And you'll also see here we've got some protection for the tip. When that just pops over the tip, and the tip can stick out of there. Not when this is on there, but that'll stick out and prevent you from wiggling it over into something and shorting out. So that's just a quick rundown on some probes. Again, if you find a real deal on a probe and it's going to match your scope, it'll this network in here will match your scope. Everything's happy. So this particular probe here, this direct reading one, the Tech P6101A, has a little less frequency capability than you might think. This particular one here has the 2 meter piece of coax on it, so its usable top end is roughly 15.5 megahertz. A little bit less than you might think, but of course you get 10 times the amount of voltage at the scope. But as long as you're working down below this is the 3 dB down point. So at this particular frequency, this will be showing roughly 70% of the voltage that you actually have at that particular spot. And also at the tip here will show roughly one megohm, because that's what your scope is. The 10 times probes have a 9 megohm built-in resistor, let's call it. They are 9 megohms in between here. So 90% of the voltage drop occurs across the probe itself, and the other 10% is at the scope. So that's why you get 1/10 of the reading going into your scope. You get 1/10 of the voltage at this point right here because of the 9 megs. Again, you can take your multimeter, take your probe, measure from tip to the center of the BNC. You should see 9 megohms right there. So we'll do a real quick probe compensation adjustment here. You can see where the hole is on this probe, and I got the little tweaking stick here. And what we're looking for is to get the top of the square waves nice and flat. You can see that this probe is more than in the middle of where this, adjustment-wise, where this scope's input capacitance is, because I can go well to both sides of what our adjustment needs to be. Looks like the adjuster's a tad on the dirty side, and that's pretty flat right there. I think we'll call it good.